Rahim. This is teacher Momen Ouda from Al-Qala'a Al-Hijazya school. So this session for grade science, grade 6. So let's get started. This is lesson 3, lesson 2, I'm sorry, page 10, thinking like a scientist. Now our goal here for this lesson is what attitudes you thinking scientifically. So here, suppose yourself you are a scientist. So how do you think about experiments, about doing experiments, about seeking for doing something that could be could reflect its benefits to the world. So here we have six steps, important steps for scientists possess create certain important attitudes, and these attitudes means like behaviors, also behaviors, scientist behaviors. Okay, first one is curiosity. Each scientist should have a curiosity about thing to seek for, to search, giving conclusions and stuff like that. Okay, so scientists want to learn more. Always scientists want to learn more. So this curiosity can be explained by scientists want to learn more. This reflect or this gives the scientist his curiosity. So point number 2, honesty. Report their observations and result truthfully. Report their observations. Each scientist should report his observation and results truthfully. Why truthfully? Because no one around the science or no one supervised or watched the scientist. So he should be honest in recording, in observation, in giving conclusions and stuff like that. Okay. 3, creativity. By experiencing problem. Now the creativity comes to the scientist by what? By experiencing problems and finding solutions. Now, each scientist should be creative by experiencing problems and finding solutions. Number 4, skepticism. Skepticism, having an attitude of doubt. Doubt. Scientists always have doubts, and by keeping scientists from accepting ideas that may be untrue. Okay, and the doubt keep the scientist from accepting ideas that may be untrue. So he always be cautious. Okay, he always be cautious. The scientist, or this point gives the scientist, or let him be what? Cautious. So let's continue. Scientists possess certain important attitudes. Number 5, ethics. Every scientist have to have good ethics. Okay, ethics are very important in doing experiments, giving solutions, giving conclusions, because these things need to be done when the scientists have a good ethics. Okay, so number 6, awareness of bias. We have 3 types of bias. Every scientist should be independent of these bias. So first one is personal bias, cultural bias, and experimental bias. He should be honest. That means this or the scientist should be honest when he does any experiment. Okay, so this is what is the meaning of awareness of bias. So let's continue now. This is what I want from lesson 2. Okay, so everyone should study from the PowerPoint file. طيب. And let's continue with lesson 3, scientific inquiry. So lesson 3, page 18, scientific inquiry. Scientific inquiry, the definition, or what does scientific inquiry means, refers to the diverse ways, means several ways, in which scientists study the natural world and propose explanations based on evidence they gather. So this or scientific inquiry can be done by what, by, or can be explained by 6 or 5. It depends on the textbook. Our textbook explains 6 stages, or I recommend to express scientific inquiry by 6 stages. I state them here. So these stages are as follows. So here, each student should memorize these stages in order. Okay, in order. This is very important. But for these stages or these steps, scientists possess certain important attitudes. The attitudes, yani it's not necessary to memorize them in order, but here each one should memorize scientific methods or inquiry in what? In order. So I wrote here each inquiry, okay, or each method, and I wrote the explanation for each one, or for this methods. So first one, ask yourself question. Ask yourself, what do I want to learn more about, or I wonder what would happen if. So each scientist asks himself before doing anything. So the question is an introduction for any experiment scientist want to do. And this method is the first method, or the introduction method, for scientific processes or scientific experiments. So to hypothesize. Hypothesizing means the scientist gives hypothesis that research to help you make an educated guess, or hypothesis. And hypothesis here means guess or educated guess. Okay, and then answer your question. And this method complete to the previous method, or this method hypothesis answer some or most of questions that scientist ask himself about before doing the experiment. So the experiment now test your hypothesis. After doing hypothesis, okay, now the scientist want to experiment his hypothesis. Test your hypothesis by making plan, by conducting an experiment. So here, practically, theoretically, questioning and hypothesis or hypothesize are theoretical methods. This one experiment is what is the first step of practical method. So test your hypothesis by making a plan and conducting an experiment. Okay. So number 4, observe and record. After making experiment, each scientist should observe and observe what's happening, the process, and record the results. طيب. Make careful observation and write down what happens. Here, number 5, analyze. After now recording observation, or observing and recording, each scientist should analyze his conclusions or his outcomes that comes from observing and recording. So use your information to draw conclusions about your experiment. Was your hypothesis correct? And analyze gives uh, gives you an answer that if your experiment is correct, or your hypothesis is correct or not correct. If not correct, you have to go back to step 3 and do experiment again. Okay, oh, I'm sorry, you have to go back to step 2, okay, and do another hypothesis, then do an experiment, observe and record, then analyze again until you reach to the right answer or right hypothesis. Now, number 6, share results. After you success in your hypothesis, or after you get a correct hypothesis, you have to share results. Explain your results by presenting your experiment observations and conclusions. He shared results with other scientists, so they can analyze your results. They can get the right conclusion or right answer for your first question, and they can tell you if your hypothesis are right, or is right or not. So this is the steps, or these steps should be memorized in order. Again, in order. Okay. Now, our last topic for today is, what is the difference between scientific theory and scientific law? Here, scientific theory, if you open your textbook page 27, what are scientific theories and laws? Scientific theory, in your textbook, as defined in your textbook, a scientific theory is a well-tested explanation for wide range of observation and experimental tests. Okay, and about the scientific law is a statement that describes what scientists expect. So here we have expectations in laws, and here in explanation for what wide range of observation for theories. And for laws, we have what we have expectations, okay, and every time under particular set of conditions. Here, laws or theories, let's start with theories, an explanation for why natural events occur develop from extensive observations, experimentation and reasoning. Here, state principle that states that occur during natural event developed from extensive observation and experimentation, yes. Here, the main difference between them, laws depends on expectation expectations, predictions, okay, and theories, it's about explanations, and observations, okay, explanations, observations, reasoning, stuff like that. Okay, this is the difference between laws and theories. Now let's continue here. It's more obvious for you, I hope. Okay, law versus theory. Law, theories here, why something happens. Laws state what will happen. Theories, explanation of nature, here predictable. Predictable here means expectations, predictable or estimate, okay, outcomes. Based on evidence. Both of them are based on evidence, so they have similarities and differences. Example, atomic theory here, Newton's law. Atomic theory, because they didn't see the atom or the nucleus, so they put theories for it. But here they saw what happened, or what explain, what predict to happen to things after they saw it, like what, like Newton's law. Okay, so this is the difference, or I think that the topic here is very clear or obvious. I give you examples and differences, similarities between theories and law. What all you have to do only to know the key difference between them. the key difference between them. As I said before here, laws about expectations, theories about explanations. Okay? So this is for our lesson today. See you next time inshallah. And assalamu alaikum wa rahmatullahi wa